let's talk about what the half-life of a radioactive substance is. Let's start off by understanding that a radioactive substance is something made of unstable isotopes. So an isotope is just an atom that has a different number of neutrons to normal, and since these isotopes are unstable, they can break down into a different element or decay. And when they decay, they release a bit of nuclear radiation, alpha, beta, or gamma. Radioactive decay is a random process, which means we have no way of predicting when an isotope is going to decay. It's a bit like with dice. You can roll a dice and you have no way of knowing whether you're going to roll a 6 or not. But if you have loads and loads and loads of dice and you roll them all at once, you can say that it's likely that a sixth of them will land on a 6 due to the nature of probability. And in the same way, if we have a radioactive substance with billions and billions and billions of unstable isotopes, we can measure how many are likely to decay every second, or every hour, or every day, or every year. And we can then say that the average amount of time it takes for half of those isotopes to decay is its half-life. The amount of time it takes for half of the substance to decay is its half-life. Great. It doesn't matter how many isotopes we start with, that amount of time will always be the same due to the probability of decay. Just like with dice, it doesn't matter whether you have 100 or 100,000 dice, it's still likely that about a sixth of them will land on a 6. So let's have a look at this graph here. We've got a graph with number of isotopes on the y-axis and time on the x-axis. If we measure the half-life, the amount of time it takes for this number to fall by half, you'll see that it then takes the same amount of time to half again and again. So the half-life is always the same no matter how much we start off with. Now it's worth noting that sometimes instead of having number of isotopes on the y-axis, we talk about activity, and it behaves in exactly the same way. The activity is just how many are decaying every single second. Number of isotopes is how many we've got left. You always get a graph shaped like this. You always measure the half-life in the same way. And the definition of half-life, once again, is the amount of time it takes for half of the substance to decay.